Hey Laura, I think you're live streaming now on YouTube, are you?
Yeah, just getting it set up.
And I'm still coming in loud and clear, I hope.
Yep, no issues.
Okay, good. For announcements of events in the past, do you have anything particularly you want me to say, or anything in the future, indeed, as well? I know I'll cover the Saturn Watch and the evening class, of course. Anything in the past? We had another Saturn Watch, of course. By the way, ladies and gentlemen,
nothing I can think of.
Okay, by the way, ladies and gentlemen, if you're listening in, we're just giving a few last minute people a chance to sign in. I see a few more have. Do you think that's everybody, Laura? I saw heavy bookings coming in. The numbers seem low.
Yeah, that could be everyone.
Okay. I'll begin in a few seconds, so just get my notes into a bigger font. Right, Laura, I think it's 5 past now. I think I'm ready to begin. Should I start the record? Am I a co-host now? Yes.
Yeah, you're now.
I know. So I'll start the Zoom recording and then go from there, shall I?
Yep.
Are we live streaming on YouTube at the moment?
Yep.
Yeah. Okay. So everything's set?
Yep.
Terrific. Here we go. The record button. It used to be there. Oh, there we are. Well, good evening, ladies and gentlemen, and welcome to this monthly meeting lecture of Astronomy Ireland. Tonight, we're delighted to have talk by Dr.
I cannot see anything. I have a blank screen in front of me.
We have a problem with someone who has a blank screen in front of him. Yes, I should apologize for that before I begin. I'm in a low bandwidth area, so I've shut off my video. You don't want to see my ugly face anyway, just so that the sound quality is good. So hopefully everyone can hear me fine, and I should be able to move during the course lecture and give you the Sky Diary notes at the end of the talk, live in person. So bear with us, everybody. My apologies. I should have mentioned that at the very beginning. So back to our plan for the evening. We always have a main speaker who's going to tell us all about an interesting aspect of their area of research. And tonight we're delighted to welcome Easy Pearson, who's a news editor of the BBC Sky at Night magazine, but also has written a book on our subject this evening, Robots in Space. So let me tell you a bit about what will happen. We'll tell you a little bit about what's been happening in the past, then our main speaker, and then a little bit about what's going to happen in the future, like the eclipse that's visible from Ireland in the next few weeks. So do hang around for 5 minutes after our main talk for any updates on the events. There's also a Saturn Watch you can come to and more. So we hold these talks every month. Our last talk, in fact, was given
there's something gone wrong here.
On the 11th of September.
Can you reach it?
Laura, I'm going to get you to mute everybody and help anybody who's having trouble, if you can, please.
Yeah.
So our last talk was, well, these talks are, I should always say, are always given on the second Monday of the month, almost always. Our last talk was given by Dr. Sean McMahon from the University of Edinburgh, who spoke all about the search for extraterrestrial biosignatures, how we might find life elsewhere in the universe. We've been very busy on the media as well. May have notice on television. If you missed that, you can go along to our YouTube channel, youtube.com/Astronomy Ireland will get you there. And you'll see a video of us talking about the supermoon that we had at the end of September, which was also the harvest moon, and also about Jupiter being in the sky next to the moon. And we actually had the details of the eclipse. So if you have to rush off, you can always get that in our YouTube channel if you'd already get it in our magazine. I've also been on national radio as well, talking about, in particular, why the Northern Lights are more common around the time of the equinox. So if you missed that, go to astronomy.ie/audio. You'll see lots of media interviews we do there. I think we get more than half them recorded and put online for people who can't listen live. So as ever, we've been keeping very busy. We had a Saturn watch as well. Clouds didn't really help very much. So we're going to repeat that on October 17th. I'll tell you about that in a moment. It's on our website as well. So as ever, we've been keeping very busy. A few announcements to tell you about after the main talk, but we want to get on with the main business of the evening. If you're not already a member of Astronomy Ireland, you're very welcome. This is Space Week. This is one of our biggest events for Space Week. So there are probably still a few events left. If you go to our own website, astronomy.ie, click on the Space Week page at the very top, and then you'll see that there is a spaceweek.ie link as well that you can follow there, which has more events happening even all around the world, all around the country, although it is World Space Week, so technically there are events running all around the world, but we'll just focus on the Irish ones. So here's our talk for Space Week. As I said, we're delighted to welcome Dr. Easy Pearson, who's the news editor for the BBC Sky at Night magazine. She had a long fascination with the night sky and has a PhD in astrophysics from Cardiff University. But more importantly, she's also written a book on the subject of robots in space. So for Space Week, we're delighted to have her tell us all about those robots and what they've been getting up to. Over to you, Easy. Or did I pronounce it Ezzy?
It is pronounced Ezzy. Sorry, my
apologies.
my mute button suddenly disappeared. Hopefully you can all hear me. Hopefully you can all see the slides. I'm sure somebody will let me know if.
Yep,
otherwise.
I'm seeing them fine.
All right, thank you very much. But yes, I am Ezzy Pearson. I am, as David said, I am the features editor over at BBC Sky at Night magazine. Basically, what that means is that I am professionally enthusiastic about space. That's my job. My job is to communicate and tell people about all of the things that are going on in space science and space exploration. But there's one area that's always really held my fascination, and that is planets, the planets of our solar system, all of the different worlds and bodies within our solar system. I just love this idea that we can actually get out there and people have been able to reach out and touch these other worlds. And that to me is absolutely fascinating. I'm just going to take a minute to pause. Can everybody please make sure that they're just muted at the moment, because I am hearing some noise from various people. So just if you can make sure that you're muted, thank you very much. But yes, so I've always loved this idea that we've been able to reach out and touch these other worlds, which is why I've written this lovely book, as was already highlighted earlier. More plugs will follow later. But as I was researching this book, as I was looking into it, it sort of became very apparent that there are basically 4 different kinds of space mission, and they're sort of increasing complexity. You have an impact mission. These tend to be the first types of mission. I've just noticed that something has happened over on the broadcast, hopefully. Okay, there we go. Hopefully you can see my slides again. But the first kind of mission is something called an impact mission. As this might suggest, this is literally where you just take a spacecraft and throw it at some kind of space rock. I believe this is Deep Impact over here on the left, which just hit that comet and glow brightly. Hit Comet Hartley, which I believe is back in the sky at the moment. And you can see all kinds of things that get thrown up by this and look at it and see it in all its wonderful glory. Then moving on from that mission in terms of complexity and cost as well, is a static lander. So these are landers that they soft touch down on the surface. So they stay in one piece. An impactor mission is a destructive mission. These survive onto the surface. They're locked into one place, but you can get lots of different kinds of instruments in one place to learn about that specific area of whatever planet they're landing on.
Sorry, are we meant to be seeing some slides? Because
Yes.
we're just seeing you at the moment.
Are you? Okay, right. Let's double check that again. Oh, hang on.
Not that we don't want to look at you, but just in case you're thinking you're listening to, we can see slides, we can't.
There should have been some slides. Hang on. Ooh. Right. Okay. So that you should be able to see my desktop now. And then when I hit that button, you should be able to see my slides. Can you see them there? Whoops. Is that coming through?
No,
Right.
not at the moment.
What about now?
Oh, sorry, that's it now,
Okay.
yeah.
Okay, so hopefully, yes, there on the left, you can see the impactor mission. That's the deep impact mission over there on the left. Next to it is a static lander mission. That's actually a model of one of the Venera landers that landed on Venus. Then next in terms of complexity is the mobile missions. I used to call these rover missions, but they're now not all rovers. These are things that can soft touch down on the surface, but then they can move about and see more of the different areas. More complex, can do more things, also more expensive. And finally, there's the most complex, the most expensive, and that's human missions to other planets and other worlds. There's only been 6 of these. Of course, the Apollo moon landings. That's the only time we've done those so far. But as I do this over the next couple of years, maybe that will change. But in this particular talk, I'm actually going to focus in on that third variety, because I did try to do the entirety history of rovers and landers in one talk, and it went on a bit long. So if you want to hear more about those, you can read to find it out in the book. But today we're just going to be talking about those rovers. So why are rovers so great? Rovers are brilliant because you can land them in one place and then move them somewhere else. There is this very big conflict that goes on in space science between safe and interesting. So on the left here, you can see where the Curiosity rover landed in that big black ellipse. So nice and flat, nice and safe. There's nothing there that's going to hurt your rover when you're landing it down on the surface. It's also very boring and not a lot scientifically interesting there, though I'm sure some geologists would argue with me on that. Then on the right, we can see this lovely jagged edge of the lots of rocks of Mount Sharp, where Curiosity is currently now, and lots of very interesting scientific things you can do there. But it's also filled with great big spikes. So it's not the sort of place that you really want to be sending your rover to when you're landing it. But if you have a mobile spacecraft, you can land it in the safe place and then move it to the interesting place, the place with all the dangerous pointy rocks. And that's one of the things that makes rovers so fascinating, and one of the reasons why people really, really love rovers, to be able to go to other worlds. But I'm getting a bit ahead of myself there, because we're talking about Mars. And the first rovers didn't actually go to Mars. They went to the moon. So I'd like to take you back in time now to the early 1970s. This is after the Apollo landings had happened, after Apollo 11 had happened. The US had won the space race, basically. And the Soviets realized by this point that there was no way that they had a hope of landing a human on the moon anytime soon. So what they were trying to do was change the story. And so what they wanted to do was change it from one where it was them racing to put a human on the moon to, well, what if we could do all of the things that the Apollo landings are doing, but we could do them with rovers instead? And they had a whole series of very, very successful lunar missions, which sent back samples from the surface, but they also sent this bad boy. This is the Lunar Cod rover. And Lunokhod literally means moon walker in Russian. So this was their moon walker. It was originally designed to support human missions, but as time wore on and they realized they just couldn't outspend the US, it was repurposed to be an entirely robotic mission. And this was the first ever planetary rover, or I suppose extraterrestrial rover, because it went to the moon, which isn't technically a planet, or even non-technically, it's just not a planet. But it taught us basically how to make a rover. And as you can see here, it's got all of the different parts that we now put on rovers. You need to have some form of communications. So hopefully you can see those two big antennas sticking out at the top. There's one that looks like a sort of black and yellow drill and another one that looks a bit like a ray gun. Those are communications antennae. And so that was how it could communicate with Earth and be able to function. It also had cameras that were allowed it to see where it was going. It had eyes, so it could drive around. It had its legs, or in this case, actually wheels, 8 wheels to be able to get around to some form of motion. All of these wheels are actually completely independently movable. They could have been ejected off. So if one of them got stuck or stopped working, they could just lose the wheel and carry on, as long as they had at least 2 on each side. On the top, you can see there's that sort of big lid that lifted up during the lunar day, and it had a great big solar panel on it, which is how it powered itself throughout the lunar day. And then when lunar night crawled around, it closed up to keep itself warm. And then finally, it had inside of that big kettle area, its brains. So how it thought, how it was able the sort of nerve center, the power, the computers. That's the word I'm looking for. And it turns out getting electronics to work in the cold vacuum of space, very difficult. So instead, what they do is they put all of the electronics in something called a WEB, or a warm electronics box. And this is basically a box that's kept at room temperature and room pressure to just make sure that everything is operating as it would on Earth. It's much easier to do it that way than it is to try and make electronics that are going to work under space conditions. So that is your 5 basic components of any rover that you're trying to make. But you also need to work out how you're going to get it to wherever you're going. I'm just going to pause for a second there, because I'm not sure you can quite appreciate it with this picture. This is actually a picture that I took at the Science Museum. This thing is massive. It's 1.5 meters tall. When I was standing next to it, it was towering over me with its antenna, and it's absolutely huge. And they needed to get that onto the surface of the moon. So how do you do that? Well, having a bunch of thrusters and things attached to your rover, that seems a bit pointless. You're going to get to the moon and you don't need them anymore. So instead, what they do is they put the rover, Lunokhod, on top of a platform. The platform has all of the bits that deal with working out how to land on the surface of the moon. And then Lunokhod just drives off and goes about its business afterwards. And that's exactly what they did. And Lunokhod 1 landed on the surface in 1971. And this was the view that it had when it landed shortly after it launched in November, 1970, sorry, not 1971. And it, as you can see, it's not a great view. There were quite a lot of issues with this rover when it first landed. One of the big ones is the fact that it was driven in real time from Earth. It's the 1970s. Computing is still very much in its infancy. It didn't have a microchip on board which could control it and let it know what it's doing. There's no fancy AI. This thing was driven in real time from Earth. There is about a 3-second delay between Earth and the moon. And to make matters worse, this was the picture that they were getting. Very, very black and white, not a lot of shades of gray. They were pretty much driving entirely by shadows. And because there's no atmosphere on the moon, the shadows are very stark. It's very difficult to make out what was going on. To make matters even worse, the cameras were put very close to the ground, so they couldn't see a large area in front of them. And they received one image every 30 seconds. So imagine trying to drive your car when you only get one picture that looks like this every 30 seconds, and there's a 3-second delay before anything that you do. It was not terribly easy. In fact, it got so stressful that the team of drivers, they ended up having to kick out some very, very high level military people who'd come to see the driving because the heart monitors on the drivers were going so high. It was so stressful, they had to wear heart monitors to make sure that their drivers weren't about to drop dead. It was a very interesting time. But still, the drivers, after a while, they managed to get the hang of driving the Lunar Cod rover. And in fact, they got a little bit too good at it. The Soviet newspaper at the time, called Pravda, I think it's called, they had a running total of how far Lunar Cod 1 had gone on the surface. And there was a bit of an obsession to get this number going higher and higher and higher. And in fact, it got so obsessed that people almost forgot what they were there for. They forgot to do science. So there was a saying that apparently the head of the mission turned around to one of the scientists and said, it's called Lunar Cod, not Lunar Stop. And there was a bit of tension there. Fortunately, they resolved that, and the rover managed to do some science whilst it was on the surface, look around, see lots of things. It lasted 10 lunar days on the surface, which is about 10 months, because obviously one lunar day, it's one full cycle of the moon, that's 29 Earth days. And it would close up every night. And then when it tried to wake up on the 11th night, the pressure inside of it suddenly dropped and it died. They think what happened is that warm electronics box, something happened to that, it cracked and it stopped working. But they weren't perturbed in the slightest. They got way more time out of it than they thought they were ever going to. And it paved the way for Lunar Cod 2. So immediately you can see from this, the cameras are a lot better. This has been cleaned up a bit, but immediately you can see that the cameras are better. So this went out in 1973, just 3 years later, but already technology had improved massively. The other big advantage was that these images could come back every second rather than every 30 seconds. So still not ideal for trying to drive in real time, but a lot better than what they were getting before. They actually went to an area that had previously been photographed by Apollo 17. And in fact, you can see its path, hopefully, here. This is the path that it took across the lunar surface. And just because it always messes, this picture always messes with my eyes a bit. I don't know about you, it's kind of like one of those magic eye things. Along the bottom, those are mountains that are sticking out of the page rather than craters that are sticking in. So hopefully that helps you work out what you're looking at a bit more. This is actually a picture that was taken from, I think this is actually a new LRO image, but the area had initially been imaged by Apollo. There was a bit more talking between the Soviets and the US at this point, so they managed to swap those pictures. And what Lunar Cod did is it drove down from its starting point in the top left, it drove down towards the mountains, along it, and then it drove along the side of this, what's called a rill. It's kind of a big canyon in the surface of the moon. And it lasted 4 lunar days on the surface this time. And what happened, they think, is on the, again, when it went to wake up on the 5th lunar day, it had overheated and it died. And they think what happened is at some point its solar panel during the day had brushed up against the side of the rill wall, and dust and debris had fallen onto the solar panel. When it closed up during the night, all of that dust fell onto the radiator and it overheated. And that's why engineers and the people who are in charge of keeping their spacecraft safe don't like it when you go up to all of the dangerous science, because the science breaks their spacecraft. But the only way that these things can do what they want to do is if you actually sort of go up to the dangerous places. But what were these things actually looked at? These two rovers looked at the composition of the lunar surface, so what it was made up of. I should note both of these went to the equatorial regions, so the regions around the middle of the moon, which were, fairly similar. And they are the only real experiments until relatively recently, which have actually looked at how the lunar surface acts in situ. The Apollo missions brought back a lot of samples that could be tested here on Earth, but the Lunokhod rovers were able to do things like essentially give the lunar regolith, it's called, the lunar soil, a poke and see how it acted, because obviously there's less gravity on the moon and things like that. And there's a lot of knowledge that they took about how the regolith acts and behaves that's going to start becoming very, very important in the coming years, because as we'll hear in a bit, there's a lot of interest in the moon again now. And so understanding how the surface physically behaves is really vital. And it's one of the few missions that have actually investigated that in situ. And the rovers did a lot of good work. The problem was that despite the Soviets' best efforts, they were overshadowed by Apollo. And to be honest, after the Apollo landings, after Apollo 11 and Apollo 13, actually, there was a kind of feeling that the moon was a bit boring. So they built, the Soviets did actually build a third Lunokhod. You saw it earlier. It's the one that was in the Science Museum. And they never got to send it because they ran out of money. Nobody was interested in going to the moon anymore. They did, in fact, sell Lunokhod 2, despite the fact it was on the moon. I'm not really sure how that one works, but if he ever wants to go and claim it, it's out there. And the Soviets did a lot of very, very cool stuff on the moon. They also did a lot of stuff on Venus that was really interesting as well. And you can read more about that in the book if you want to. But unfortunately, there is a sort of feeling now that the Soviets don't tend to be, Soviet space mission isn't really remembered for their victories at the moon or Venus. What they're better known for are their failures at Mars. The Soviets tried to land on Mars, I think it was something like 18 times, and they have failed every time. And it's not gone great for them. What this did mean instead was that Mars has become sort of the purview of NASA. So it's NASA that has gone there to explore it. And the moon draw people's attention because it's our nearest neighbor. It's got a strong connection with Earth. Mars has attracted people's attention because of this idea that maybe once upon a time, it might have harbored some kind of life on the surface. And so people have been absolutely fascinated with Mars for years and years and years. In the 1970s, the Viking missions went, and they actually had 3 experiments on it trying to find life on the surface, and they didn't find anything. And unfortunately, that did sort of put Mars research or Mars surface landing missions back a bit, because everyone went, well, we went to Mars, we didn't find anything, what's the point? In truth, the Viking missions, even if there had been life, the chances of them finding life was very remote anyway. And there was a long period where Mars was kind of a bit of the black sheep of the planetary family, and there were no missions going over to Mars. And it wasn't until the 1990s that people started talking about it again and started working out, well, maybe if we did want to find out whether there could have been life on Mars at some point in the past, the only way we're ever really going to work that out is if we get a piece of Mars and bring it back home. And so NASA started developing their Mars sample return mission. And this was, in the 1990s, it was sort of a thought experiment because they very quickly realized it was going to be way, way, way too expensive. It was going to cost $10 billion, which by today's numbers, they spend that relatively frequently on space missions. But back in 1990, that was just way too much money for them to mount a mission like this. So it got put to the side, and instead they started looking around for a cheaper mission that they could do. And what they came up with was the Mars Environmental Survey. The idea behind this mission was that it was going to be, rather than having one big mission that potentially, rather than having one rover that costs $10 billion, if it blows up on the rocket, that's $10 billion gone up in smoke. But if you have 16 smaller stations, if one of them blows up, it's annoying. It's still a waste of money, but it's not the end of the mission. And they could work together to be greater than the sum of their parts and form this entire global monitoring station around Mars. At least that was the idea. They made a test mission first, which they called Pathfinder. And if you hadn't already worked out what this was, the term Pathfinder might spark a few memories for you. This was going to be just the one mission that they were going to send off to test the technology, see if it worked. And they developed this tetrahedral shape that was going to be the lander. So it would be a big landing station in the middle, these 3 petals, they were called, with big solar panels on them that could fold out. It didn't matter which side it landed on, it could unfold itself and right itself and be able to observe. But as the mission goes on, they realized what they really want to have is something called an APXS on the mission, and that is an alpha proton X-ray spectrometer. It is basically a device which can look at the rocks and the surface that's surrounding it, that's in front of it, and it can tell some of the chemical composition that is within that rock. It's a very sophisticated instrument and a sort of backbone of a lot of planetary geological science. But as they were putting together this Pathfinder mission, they began to realize that there was actually quite a lot of room left in the lander when it was in its folded up configuration. In fact, there's probably enough room to put a rover, just a small one, but they could fit a rover on it. And that would be really useful, because if they took that APXS, that spectrometer, and put it on a rover, it could go all around the surrounding area and be able to look at all of these different things around it. It would massively improve the scientific return on the mission for what could potentially be not that much of a cost. So the Pathfinder mission cost a relatively cheap $150 million. I always feel strange when you're talking about space missions, and it was like $150 million. That's nothing, but it is in the terms of things. And the rover, potentially, that could be probably would only cost about another $20 million. So not a very big outlay for the potential scientific return of it. And what they came up with was this little rover here that you can see down on that front pedal, all folded up, ready to fly off to Mars. And that is the Sojourner rover. And here is a little diagram of what the Sojourner rover looks like. You might notice it does actually look very similar to the Lunokhod rover. It's got its solar panel on the top for its power. It's got wheels. But this was one of the really big developments with Sojourner. It's something called the Rocker Boogie system. And this is the wheel arrangement that is being used on pretty much every NASA rover since, and a lot of other rovers as well, both extraterrestrial and a lot of the ones here on Earth. And what it is the front 2 wheels are connected by a U-shaped bar, and then the back wheel is connected to that with another bar. And this means that all 3 wheels can move up and down independently, both on each side, and can go over all kinds of uneven terrain. It's much more simple than having to control 8 wheels that can move completely independently. And it's a very elegant system, and a very, very simple one as well, to be able to navigate all of these kinds of strange terrains. It also had its cameras, it had its eyes. These were very simple because it was such a small rover. It was about, I think, 50 centimeters long. So about the length of a skateboard. It really was not a very big rover at all. But there were some big differences. One of the big differences was the fact it could only have a short-term antennae. One of the problems with it being so small is it only had a very small solar panel, which meant it just didn't have the power to be able to communicate all the way back with Earth. So instead, what it did was that antenna communicated with Pathfinder, and then Pathfinder would communicate back to Earth. So it was a sort of putting in a middleman to boost the signal, because Pathfinder had this absolutely massive solar panels. It didn't have a problem with getting a signal all the way back home. It also had a much more advanced computer system. It had microchips on board, which were able to store instructions and be able to drive around the surface. Because one of the big problems with Mars is you cannot drive in real time. There is a minimum 8-minute delay between Earth and Mars. And so if you were trying to do a movement, get your image back, send another order to the spacecraft, get the image back, it would just take absolutely forever to do anything. So instead, what Sojourner could do was it would send its pictures back. People on Earth would work out a set of instructions to send it to. It would then follow through those instructions. It had a couple of fail safes involved to make sure that if it felt like it was tipping, it would save itself. So very simplistic by today's standards, but absolutely leaps and bounds beyond what we could do with Lunokhod. And it meant that it could operate by itself on the surface of Mars. So they made Sojourner, they packed it up, they put it on Pathfinder, and they launched it in the 4th of December, 1996. It landed on the 4th of July, Independence Day over in the States, in 1997. And there was another innovation with this particular lander, because there's a big problem with Mars. There is a reason why so the Soviets had such trouble landing on Mars. It is exactly wrong in so many ways. If you have too much, it's got a bit of an atmosphere. The moon has no atmosphere, Mars has a bit of an atmosphere. Unfortunately, it's too much of an atmosphere that you can ignore it completely, like you can on the moon. But it's not enough of an atmosphere that you can use parachutes to slow down. So instead, it needs to have a complicated mixture of thrusters and parachutes and aerobraking to slow down. But in the case of Pathfinder, that still wasn't enough. It was still going too fast when it was hitting the surface. So they needed something to absorb that last little bit of energy when it struck the surface so it could land safely. And the way that they did that was by wrapping it in bubble wrap, or more accurately, in a series of these huge inflatable balls that covered all over the surface. And basically, when it was just about to hit the surface, these inflated, that soaked up that last little bit of force as it hit the ground and kept Pathfinder inside nice and safe. They then withdrew inside after it landed safely, and allowed Pathfinder to open up and reveal itself onto the surface. And this was the view that it found when it got there. And just so you're aware, this is actually an image that's supposed to be viewed with 3D glasses, like the old-fashioned blue and red ones, because that was something that Pathfinder could do, and a lot of their images are in that configuration. But this was the first ever view that Pathfinder had. It could see Sojourner still all hunkered down for its flight to Mars there on the surface. And you can hopefully see there's sort of two gold barrels in front of and behind the rover. Those are the ramps They are coiled up inside. They use a similar sort of idea as behind you get on measuring tapes, the metal measuring tapes. It's that sort of thing that allowed these ramps to be rolled up nice and small. But they then deployed onto the surface, one at the front, one at the back, and then it allowed Sojourner, once it had righted itself, to roll off onto the surface. And hopefully, here you go. Because some bright spark at NASA thought, we've got all of these cameras, why not capture it going onto the surface? And that was what Sojourner looked like. And here she is on the surface. And I called her she there because at NASA, all of the Mars rovers are female. That was a tradition that was started by Donna Shirley, who was one of the people who arranged the Sojourner mission. And here's Sojourner on the surface. It was the first time that it rolled out. And Sojourner transmitted from the surface of Mars for 82 sols, which is 82 Martian lunar days. A sol is about 24 hours and I think 40 minutes, 38 minutes. That's how long a Mars lunar day is. So slightly longer than the Earth day, which does cause some problems when you're operating on a Mars mission and you're working in Mars time, but living in human time. And this is the area around it where it explored. This is what's called this area called the rock garden. So lots of rocks all over the place, absolute grab bag of these rocks all over the place. So the geologists were very happy when they looked out and saw this is what they got to play with, especially that they had Sojourner, the rover, with that APXS on board that could look at all the different mineralogy that was around here. And during its time on the surface, it looked at all of these different rocks, and they all were given names like Yogi and Zaphod from Hitchhiker's Guide to the Galaxy. I think there's an Indiana Jones there. There's a couple of mountains, which I don't think you can quite see in the peak in the background, that were called Twin Peaks after a TV show at the time, because this is what happens when you let space nerds name things on other planets. And so they explored this area for its 82 sols. And what they found here was that there was evidence that there had been, in the distant past of Mars, some kind of catastrophic flood, because all of these rocks were completely different. None of them seemed to have come from where they were right now, at least not in any way that made sense to geologists. They were all completely different, all seemed to have different formation stories. And so what they thought had happened is that a giant flood in Mars's dim and distant past had brought them all down. It would explain why they were all pointing in the same direction, and why there's such a mixture, such a grab bag. And there's even some rounded pebbles in there, so ones that look like they'd been buffeted around in a river or a stream, just as we see here on Earth. And so Sojourner did find out quite a lot on the surface of Mars. But one of the things it really did was it taught the people at NASA just how much rovers could do if you let them go in a location like this. There's so much that they can achieve. And so they came up with something called their decadal plan. And the decadal plan was basically NASA wanted to send a mission to Mars every window of opportunity for 10 years. You can fly to Mars every 2 years and 2 months. That's when the planets are aligned, and you're not having to fly halfway across the solar system just to get to the other side of the sun. And they wanted to make sure that they had a mission on there. And one of the reasons why people were so interested was because Sojourner had found evidence that there might have been water in Mars's past. And that was an absolutely huge thing. And because here on Earth, where you find water, you find life. And the idea that if there had been water in the past on Mars, then that would mean there was a much bigger potential that there might have also been life in the past on Mars. So people were really interested in trying to investigate that. The start of their decadal plan was in 2003. That was the mission that they were heading for. So Sojourner happened in 1995. They wanted to send something, 1997, and they wanted to send something in 2003. And the reason for that was because it was Mars's closest approach for many, many years. I think something like 60,000 years, it would be their closest approach, which meant basically you could get more bang for your buck. The rocket didn't have to send the mission as far, so you could send something that was much heavier. And what they really wanted to do, having seen Sojourner's success, was they really wanted to send a rover, basically a bigger version of Sojourner that they could send. And this is what that mission entailed. They eventually came up with something called the Mars Exploration Rovers, or MERS. And they were basically robotic geologists that they were going to send to Mars to be able to investigate the area around it. And it had 4 main goals: to characterize the planet's past and present climate, to examine the geology of the region, to find out if Mars could have had life, not if Mars did have life, which was the mistake they made on Viking, but just if it could, like, if the ingredients of life were potentially there. And the final one was to prepare the way for human exploration. That final point was pretty much, can we land something heavy on Mars? In terms of preparing the way for human exploration, a little bit of also working out what is on the surface of Mars that might potentially be useful to people in the future if they want to live there long term. But the first 3, they were very much concentrated around looking for the history of water on planet and track water on the planet, and also discover whether there had actually been water in the past on Mars. Because Sojourner had hinted at it, but there were other explanations. They wanted something a bit more concrete. And once they had these goals, they went away and designed their rover. And this is what they came up with, which, if you look at it, it's basically just a big version of Sojourner with a taller camera and a bigger solar panel plugged on top. And it was very, very much based on Sojourner. It had these bigger solar panels, actually had these, what they called sort of jet plane racing wings designs to it, which was basically a very clever plan to try and get more strings of solar panels, as they're called, in there so they could get even more power and the mission could last even longer. It had much better cameras, and particularly it had much higher cameras. As the Lunokhod people discovered, the higher your cameras are, the more around you can see, the easier it is to navigate. It allowed the rover to be able to see much more. They were better quality. It had 2 of them, so it could get that sort of stereo vision, which again helps you judge distances and things, because that's one of the big problems with, even though Mars does have an atmosphere, which helps you with judging distances, it's a very, very thin atmosphere. And so on short distances, you really do need a bit of help. You need that sort of spectroscopic view to be able to see. It also had a robotic arm, which you can hopefully see sticking out of the front. And on the end of this, there was a microscope, that APXS that they put on Sojourner, as well as even some more fancier spectrometers, so things that be able to tell even more about the rocks and the elements that they contained. And they also had something called a RAT, or a rock abrasion tool, which was basically like a scrubbing brush that went up, scratched away at the surface, and revealed the pristine rock underneath. So they sent these rovers to Mars, and they didn't just send 1, they sent 2. They were called Spirit and Opportunity, and they sent 2 because the chances, it doesn't cost that much. Most of the cost in a space mission is R&D, research and development. Actually, building a second one doesn't cost that much more, relatively speaking. But it massively increases your chance of success. Because if there's a 10% chance that 1 could fail, the chances of 2 failing is much, much less than that. because both would have to fail. So they sent these two to the surface, and they arrived in 2003, I think. They launched in the summer of 2003 and reached Mars with pretty much no problem. In fact, here the two of them are being built. This was just before they were packed up to get put away and get sent to the surface. And so here is Spirit, I believe this is, on the surface of Mars, looking all around it. So they got to Mars, no problems, everything was very, very good. Their development and their building, lots and lots of problems there. But once they actually got to the surface of Mars, after a few teething troubles, they did spectacularly, both of them did. And in fact, they lasted a lot longer than anybody was expecting them to. These things were designed to last for 90 sols. NASA hoped they'd last a bit longer. They always build these things with massive leniencies in it and sort of safety margins. But there was one big factor that was going to really limit them on Mars, and that was the dust. So here you can see all of their solar panels are covered in really thick layers of dust. And they'd seen this with Sojourner. And over time, the dust builds and builds and builds on the solar panels until the point where it just can't get any more power from the sun. It's not getting enough power to be able to operate. And so they knew they'd be able to get 90 sols. They hoped they could get maybe a year, maybe 2 years, so an entire Martian year on the surface. And then something weird happened. In December of 2005, they came in one day and looked at the power levels on Spirit and realized they'd gone up by about 10%, which nobody was expecting. And then a couple of months later, the same thing happened on the other rover. And what had happened is something that they called a dust cleaning event. Some wind event had come along and swept away a whole bunch of dust off of the solar panels, and it could absorb a lot more energy from the sun again. It could keep on going. And suddenly they'd gone from a mission that had this deadline over it, this sort of sword of Damocles hanging over it, to a mission that could potentially go on indefinitely. They could basically now run these rovers until they fell apart. And that is exactly what they did. Spirit landed in an area called Gusev Crater in 2004. Gusev Crater was believed to be a former ocean. There's lots of evidence of hydrothermal activity from surface, from orbital images. And here on Earth, we think the hydrothermal vents on Earth are where life originated. So very interesting place to look on the equivalent place on another planet. It was very mountainous place, lots of rocks and pebbles and bits and pieces, all strewn all over the place. Again, you tend to find that in lots of places where water's been running through because it brings it along. And it operated for 6 years in Gusev Crater, traveled about 7.7 kilometers across the area. And then on the 22nd of March, 2010, it had its last communication with Earth. Unfortunately, shortly before that, it had gotten stuck in a sand pit. NASA tried everything they could to get it out, but unfortunately, it was just stuck really fast, and they couldn't orientate it properly to compensate and get ready for when the Martian night was rolling around, and it just got too cold and it stopped operating. But still, I think Sojourner traveled about 500 meters and Spirit did 7 kilometers. So pretty good going on Spirit's behalf. Then we have Opportunity, and Opportunity ran until began in 2004. That's when it landed in a place called Meridiani Planum, which is a very, very different terrain. Lots of big open plains. I love this picture over on the right. It's one of my favorite space pictures. Everywhere else that we'd seen on the Mars surface until then had been this sort of rock-hewn surface. And then there was this absolutely pristine desert streaming out into the darkness, distance that Opportunity revealed. and it traversed a huge distance across this. It was going for 14 years before it finally stopped working. It traveled 45 kilometers, it beat out Lunar Cod for the first time. And unfortunately, as a lot of you might remember, back in 2018, a huge global dust storm came in and swept across the surface of Mars, and just it didn't survive that unfortunate meeting. There is a very famous quote where it said, "It's getting dark and I'm shutting down now," or something like that, where it wasn't able to its last communication back to Earth. So that was very sad. But between the two of them, they had operated for 20 years on the surface of Mars, which is a huge amount of time. It's an absurd amount of time, and I think you could have an entire conference talking about what these two rovers did during that time. So I will summarize as best as I can. The biggest thing that they discovered was pretty much conclusive proof that there was definitely water at some point in the past on Mars. They found various different minerals, things like clays and carbonates and hematite, particularly, which you cannot create, or at least we don't know of any way you can create without water. So very, very strong evidence that there was some kind of water in the past. Spirit, however, found that this water looked very acidic. All of the geology around it was saying that this was rocks that formed in acidic conditions. But Opportunity said that the water would have been neutral, so much more like what we would find on Earth. So there's some evidence that there's been some past shift in Mars's climate whilst during its wet phase, when it was still wet on the surface. So there is some kind of shift going on there in the environment. But that has led to a lot of questions about what was going on with the history of water on Mars in the past. And it also really got people interested in sending something that could look a bit more focused on searching for signs of life, particularly something called organics. That doesn't mean stuff that's created by biology. It's more the building blocks of life. So carbon-based molecules, hydrocarbon molecules that form the building blocks that all life that we know of or here on Earth were built from. And in order to really investigate that, they were going to need another rover, but it was going to have to be much bigger and much better. And in fact, you can see how much bigger it was because you can see it here. So down at the front, we have Sojourner, or an analog for Sojourner. Then on the left, we have Spirit and Opportunity. That's about the size that they were. And then on the right, we have this bad boy. This is Curiosity. Absolutely huge, massive rover. And that caused a bit of a problem. And the reason why you need to have such a big rover is because if you really want to look at these hydrocarbons, you have to be able to break them down. And that means you need to have an oven that can cook them. Cooks them, breaks them apart, and then instruments on board can look at all of those various different molecules and work out what's there. That requires much more power. So you need to have an RTG, a radiothermal generator, which is basically a radioactive brick. And I believe it's plutonium, which is really heavy. It's heavier than lead. So this was a very big, very heavy rover. And the question became, how do you land it? Spirit and Opportunity had pretty much used the same they'd used a hollowed out Pathfinder, but that had really pushed the limits of what you could do with that landing technology. There was a lot of work trying to make sure that the parachutes didn't absolutely shred themselves when they landed. It just wasn't going to work for something like Curiosity, which was the name that they gave to this new rover that they were going to build. Was originally called the MSL, or Mars Science Laboratory, but Curiosity was the popular name that was given to it and the one that everybody knows it by. So what they said instead came up with, we can't land it in a box, so why don't we land it on its wheels? Which was, to quote somebody on the team, it's crazy, but it's the right kind of crazy. And they developed this, it's called the Sky Crane. So it's basically a sort of hovering device, which would, after the parachutes and aerobraking had slowed down the spacecraft as much as it could, this device would fire its thrusters to slow down the rover as it came towards the surface. It would drop the rover beneath it, and then the rover would land on its wheels, at which point the cables would cut away and this Sky Crane, would jet off into the distance and crash somewhere where it wasn't going to hurt anybody. This would be very important if there's ever going to be a human mission, because it means you can land much, much heavier things. It also means that you can really precision land, which is hugely important. So this is exactly where Curiosity landed. This is a region called the Gale Crater. It's the site of a potential lake in Mars's past. There's a big mountain in the middle, which is made from sediment. And you can see that's the landing ring. And normally with something like Spirit and Opportunity, they needed to have a much, much bigger area because they couldn't predict exactly where they were going to land. But because Curiosity could be much more precision landed, they could land it in this relatively small flat area and then be much closer to the area that they really wanted to go investigate, which was Gale Crater in the middle. And the reason why they wanted to investigate Gale Crater is because it was a sedimentary mountain. It had been laid down over the years. There was a lake in the middle, and then every year that water had laid down sediment on top of sediment and built up this mountain in the middle, which meant when you look at it now, you can see all of the layers from those various, it being laid down. And that meant if you can drive up those layers with Curiosity, you could effectively drive through the history, the geological history of Gale Crater. And from that, as you're driving through the geological history, you're also looking at the environmental history. You're seeing what the planet was like when those layers were put down and when it was created. And so Curiosity left, went to Mars in 2011, landed on the surface in 2012. It is still going strong. It has traveled 29 kilometers. That number's outdated. It's more than that now, but it's in the 30s at the moment and still going strong, still climbing its way up of Gale Crater. And it's constantly unveiling new different kinds of things about the surface. One of the big things that it found was that it looks like the history of water on Mars is a bit more complicated than first thought. It wasn't just there was a period when it was wet. It looked like there might have been some kind of flash floods, perhaps caused by a meteor impact, melting some ice or something like that. So rather than it being constantly wet, it was these brief periods. It's also found tantalizing tints of methane in the atmosphere. Those are still a bit controversial because nothing else has been able to observe them, none of the orbiters in orbit, but it has definitely found other organics in the rocks. So there are definitely those building blocks of life on Mars. There are the ingredients of, there's water, or there was water at some point, and there were hydrocarbons. So life is definitely possible, perhaps not plausible, but possible on the surface of Mars. To really be able to tell if there is any kind of life history, they really need to mount a sample return mission. And as of a couple of years ago, that mission is now in operation. So they worked it out back in the 1990s how they were going to do this, and basically need 3 phases. You need one mission that is going to send a rover to Mars, pick up a bunch of samples and put them all together in one place. You then send a second mission with a fetch rover that picks up all those samples, puts them in a capsule, launches it into space, where a third mission comes along, catches it and returns it to Earth. It's the first stage of that mission is now currently underway. It's called Perseverance. And here we can see Perseverance landed back in 2020 and has been driving around on the surface since 2021. It's basically an even bigger, beefier version of Curiosity. It's got all of the same bits on Curiosity. but technological developments mean they can make it smaller and lighter. And it's also got all of this hardware to be able to create these caches. So small test tubes, well, actually quite big test tubes, of samples that it would store and then leave for that fetch rover to come. And here it was landing on the surface, because somebody in their infinite wisdom thought, do you know what would be really cool if we actually put a camera on the sky crane so you can see it landing. But it also didn't go to Mars alone. It went with Ingenuity, a helicopter scout, which is why I have to say mobile spacecraft at the beginning of this talk and not rovers, because we now have spacecraft that can fly on the surface of another planet. And so this is basically, it's a similar concept to like a drone. It uses rotors like a helicopter to fly short distances across the surface. Short distances, I think the most it's done is about 500 meters. And this is really, really useful because even though this can't take a lot of weight, so it can't, have scientific instruments on board, it has a camera, which means it can scout the way ahead for Perseverance. So this is one of the very early shot from Perseverance as it's flying through the air. And look, it can see Perseverance over there in the corner. And it's looking at the landscape that Perseverance has to traverse, and it can work out, are there any obstacles, work out ways that it can go around. And as a result, Perseverance has able to absolutely motor it across the surface of Mars. I've forgotten to look up exactly how far it's gone now, but it's gone a huge distance, much further than they were expecting or hoping to. So Ingenuity, it was meant to be a test for these kinds of spacecraft, but it has been an absolutely huge benefit to the mission. And it's allowed Perseverance to go around and collect all of these test tubes, which it has then left across the surface. Most of them are staying on board the rover, but I was about to say a couple of months ago, I think it's about a year ago now, it created this safety cache on the surface where it left 10 test tubes on the surface in a very known location so that should something happen to Perseverance, the fetch rover can just go and pick these up. I always get a bit kind of blown away by the fact they're just left on the surface. I sort of imagine they'd be in like some kind of box or something, but no, they're just scattered across the surface. I don't know why I think something's going to happen to them, but it does worry me slightly. So that's what's going on Mars at the moment. So lots and lots of things happening there. Very exciting place to be. But there's also a lot of interest back in the moon again. Lots of people very interested going back to the moon. Basically in 2009, I think it was, the Chandrayaan-1 orbiter found, it was 2013, the Chandrayaan-1 orbiter found potential signs of water ice at the southern poles. So people got very, very excited about that. And there's a lot of interest in Mars again, the moon again. One group of people who are very interested in getting over there are the Chinese. China has been really throwing its all into its space program recently. It sent its U2 rover, which means Jade Rabbit in Chinese. It's based on a Chinese lunar myth. Landed in December 2013. It operated on the surface for 42 days before it became immobile. They were hoping for a bit longer. Then in 2019, the first ever mission to the lunar far side landed with its U2 rover. I have to be careful how you say that, which landed on the lunar far side. Unfortunately, a lot of geologists were a bit annoyed by that because they'd taken that APXS off, that thing that could have told them what the composition of the lunar far side was like. They'd taken that off because they didn't want it to get stuck like the previous one had. It also doesn't help that the Chinese aren't terribly forthcoming with what's going on with their space missions. but never mind. And then in 2021, China also landed a small rover called Tianwen-1 on the surface of Mars for the first time. So they became the second people to have ever landed on the surface of Mars, ever soft landed on the surface of Mars. And here's the rover. It took its own camera with it. It's not a staged photo. This is actually from the surface of Mars. So they've been doing lots of really exciting things with their rovers. And this is actually the first time I've been able to talk about these next people, which is India. So previously, when I've given this talk, I've then said China's the only people that have gone to Mars, but there's been lots of people who have tried. There's been quite a few people who have tried to land on the moon and failed, including ISRO. They tried back in 2019 and crashed. And then they tried again about a month ago to land with their Chandrayaan-3 lander, the Vikram lander, it was called, and they succeeded. So it's very good for them. And this is the lander that you can see on the surface. And this is what their little rover looks like. So both the Chinese rovers and this Pragyan rover, they are very small. They're kind of more Sojourner sized than Curiosity sized. And we're actually seeing a big surge in these small rovers on the surface of the moon, or trying to go to the moon. Because they found this water on the surface of the moon, potentially hidden in the craters at the southern pole, there's been this huge resurgence in interest in going to the moon. NASA has launched their Artemis program, which they want to send humans back to the surface of the moon by the end of the decade. And to do that, they're going to need a lot of missions to help support them, both in terms of helping them run the missions themselves, but also to investigate the lay of the land beforehand. And so that's why there's a lot of these missions. And in order to do that, NASA sort of almost farmed out that responsibility a bit. It's done it partly towards private enterprises. So there's quite a few private enterprises. There's a company called Astrobotic, which are planning to send a lunar lander by the end of the year. I believe November is the date they've had in their diary. And up until now, I've always been saying the next time I give this talk, I hope to be able to say that. They've finally gone and they've landed on the surface. And I'm still saying that I hope that they've gone and landed on the surface the next time I give this talk, but fingers crossed. And also there is these international partners as well who are going to the surface of the moon and exploring the area. And most of these have been going to that lunar South Pole. So the Chandrayaan, the Indian mission, went to the South Pole, investigating the area around that. But it's not just the moon and Mars that people are really getting interested in. With the development and success of Ingenuity, there's people looking at all kinds of weird and wonderful things, not just rovers, but also flyers. This is the Dragonfly mission on the left that's hopefully going to be going to Titan in the next couple of years. And then there's also a lot of interest in going to Titan is the icy moon of Saturn. These icy moons are potentially have liquid water oceans underneath them. Well, Titan has liquid methane oceans, but other of the icy moons have liquid water oceans on them. And there's all kinds of weird and wonderful missions that people are developing to be able to get down into those oceans and check out that water and see what's going on down there. So lots of really, really interesting things going on in the field of mobile research happening all over the solar system. And it's a really exciting time to be interested in the planetary exploration. That is, however, rovers are only part of the story. Landers, static landers, are also a hugely important part. And if you would like to find out more about those, then you can always read about them in my book, Robots in Space, which is available for purchase. If you'd like a signed copy, please do contact me on one of the methods on the supply there, and we'll sort something out. But that's my plug over, and it's also my talk over. So thank you very much for taking the time to listen to me. Sorry if I rushed through a bit at the end there, but if anybody has any questions, please do feel free to ask. I'd love to hear from you. Thank you very much.
Thank you very much indeed, Ezzy. Well, we have just a few minutes left for questions. Now you have to rush off a little bit. And if anyone wants to ask any, you can actually just unmute your microphone, shout away. And if not, you can post them in chat. And I don't know if you can see them yourself, Ezzy, in the chat, but
Yes.
already I noticed popping up.
Oh, is somebody talking at me?
That's me.
Okay. I will. Okay, the first one I saw is, do you know materials used to make the rovers are mainly metal-based or plastic-based? I think they're mostly metal-based, just because plastic isn't robust enough. I know you can get some pretty tough plastics, but they can't compare to metal. Both particularly the moon and Mars, because there's not much an atmosphere there, there's not much water history. The dust doesn't wear down like it does here on Earth, and it's very, very abrasive. So you need something that's going to be able to withstand that. So most stuff's made out of metal. There's the odd bit that's made from plastic to kind of keep weight down, or because it's more useful. And also they make it out of things like titanium and various other quite expensive but very lightweight metals. So there's lots of different parts that go into making a rover.
We have one other question I can see there, and we do want people to stay with us just for a few minutes after the talk, because we have to tell everybody about the eclipse and the two events that are coming up. And it's still Space Week, so maybe we'll take this as the last question. If another one's popped in. So two last quick questions.
Which is my favorite robot? Oh, that's hard to ask. I have to say I quite like Huygens, which is the one that landed on Titan. The story behind that and how things that I'm a big fan of when things go wrong. And I kind of glossed over it a bit there, but a lot of things went wrong when they were developing Spirit and Opportunity, including the cork peeling off of the rocket, which is, why is there cork on a rocket? But Huygens, I just love the idea that they sent this spacecraft off in the hope that it was going to float on a methane ocean on a moon of Saturn, looking down on the rings, and that's very romantic to me, so I like that one. Okay, another question. Are there any applications on Earth resulting from the knowledge gained, e.g. bottom of ocean inside of volcanoes? It's kind of hard to say, because so much of rover research feeds into each other. And so a lot of the people making these rovers nicked stuff from people who are making them for for deep sea explorations, and also things like going into nuclear reactors, other places where you don't really want to send people. Because that's one of the things, if you're going into space, it needs to be able to withstand radiation a lot more than something on Earth does. So I think it's nuclear reactors is the one that gets a lot of cross play on that front. But basically they all feed into each other. All of the different teams talk to each other and swap tricks. So yeah, absolutely, there are definitely cross things there. And I've also just seen another comment about AI. There's definitely, that is one of the big advancements that's happened, is how well these rovers can think for themselves. Sojourner, basically it needed to get told exactly what it would do, and it had a couple of things on board which stopped it going into a pit. Whereas Perseverance, basically they can say, go to that rock over there, and it works out how to do that by itself. So huge developments in the computing side of things as well. So whether I've noticed space people, they don't like calling it AI. It's always machine learning and things like that. I don't know the differences between them all, but definitely advances in computing are going to be a huge thing there. So I think that was all of the questions.
Fantastic, Ezzy. Thank you so much indeed. This has been our Space Week lecture. I can hardly think of a better topic. Hopefully, everybody rushing out to buy the book.
I hope you
And by the
enjoyed
way,
it.
I'm sure, Ezzy, you won't mind. Your email address is there on screen. If anybody has any
Yes.
questions, they're scared to ask in public, they can always contact you that way.
Yes, absolutely. My inbox is always open. It's sometimes a bit late. But if any questions or you want to find out anything, please don't hesitate to get in contact.
Well, we can't thank you enough. We're going to tell people about the eclipse now. And
Okay.
I know you have to rush off. So thank you very much indeed for joining us during Space Week. We appreciate it. And on a sort of BBC link, the Sky at Night's on tonight at 10 o'clock, isn't it? The Question Time special. I know you
Yes.
work the magazine side.
Yes, I'm trying to remember what date it is because I constantly work 2 months ahead. So
It's tonight, and it's repeated actually on Thursday about 7 p.m. on BBC
Yes.
4.
Okay. Anyway, thank you very much again. Bye-bye.
Thank you again very much. Easy. Okay, well, look, Space Week continues. Some of you got along to my talk in Malahide Library last week. Our Phoenix FM interview is there on astronomy.ie/audio. But now I want to tell you briefly what's happening in the sky. Most of it's in the magazine, so I'll just remind you. If you're not a member of Astronomy Ireland yet getting the magazine, please sign up online, astronomy.ie. We want everybody in the country to join. Certainly don't need telescopes but even binoculars, just an interest in knowing more. If you've watched this talk, you're definitely one of us. So a lot of you are members already. Great. Please tell all your friends and family to join. The rest, please join a couple of minutes when I finish talking. I'll keep it brief. The International Space Station was in the evening skies until last week. It'll reappear on October 21st, but in morning skies. So for the rest of this month, I'm afraid, no evening passes. The planets on view. In the evening sky, we've got Saturn and Jupiter. We'll have a Saturn watch. I'll tell you about just a second. Jupiter's blazing away. You can't miss it after about 8 o'clock. It's up, rising over in the east. Mercury just made its best morning show of the year. If you like getting up at the crack of dawn, if not, wait till spring next year. You'll see it in the evening sky. And Venus is at its very best in the morning skies. Its greatest elongation west, in fact, is on the 23rd of October. But all this month, it's amazing. If you happen to get up just before dawn, you can't have missed Venus. It is that incredibly bright. Other quick things are on view. This morning, they launched another batch of 20 odd of those Starlink satellites, which I know are worrying us all about light pollution, but they do look very spectacular. They passed over this evening at 18 minutes past 8. Missed them this evening, but we'll keep issuing predictions for about a week till they get to higher orbits and they fade away. But they really do look quite spectacular, I have to say, when they're extremely close together. Then other events are happening tonight. If you want to get up at dawn to watch Venus, tonight's a great night to do it because it's going to be near the moon, 6 degrees below the moon, in fact. The moon's a lovely crescent as well. And the star Regulus, brightest star Leo, is just near Venus. In fact, they're closest as well. So tomorrow morning couldn't be a better time to set your alarm for around 6 a.m. You have an hour or so. More details in the magazine, including a diagram showing what the scene will look like. This Saturday then is a new moon. Wouldn't normally be of interest, except there's going to be an annular solar eclipse. Now, we won't see it, but they will in continental USA, where a lot of people live, with a lot of internet access, and you be sure you're going to hear loads about this eclipse, the annular eclipse, crossing the states on Saturday. Then for us, back to us, in daylight on Wednesday next week, we're going to have the bright star Antares be covered by the moon. Now, you won't be able to see the star normally easily, but if you have a telescope, you should be able to locate the moon in daylight in the south, and then you will see the star passing behind the moon. There's more details of that in the magazine as well. Going toward the end of the month, Sunday the 22nd of October, in fact, Saturday night, Sunday morning, is the Orionid meteor shower peak. A reasonably good shower, not as good as the Geminids or Perseids in August and December, but details of that are in the magazine as well, just to remind you. Then we're going all the way to the 24th of October when Saturn is near the moon. It won't be particularly close this time, but there is a diagram in the magazine showing what to watch out for. So if you don't know which star in the sky is Saturn, it's in the top 10 brightest stars in the sky. If you're a beginner, the moon will help you. And there's a diagram in the magazine to show you exactly where to look relative to the moon. And then the last Saturday of the month is the big event. It's a full moon. In fact, the Hunter's moon. but it's also going to be a partial lunar eclipse. Now, that means that the moon's going to clip the Earth's shadow. Only about 12% of the moon gets inside the Earth's shadow, but a good chunk of the rest of the moon will darken away, and 12% will be missing around about 9:15 on the 28th of October. It's actually the night that the clocks go back. So you're going to lose an hour's sleep that night as well. Or do we get an hour's sleep extra? Oh, we'll work that out later. But it's last Saturday of the month. It'll actually start earlier than that. So around about 8:30 to 10 o'clock, you can see something happening. All those details are in the magazine. It's a special page devoted to it, page 29, I think it is, in the October magazine. So you know, remember, you have plenty of time to order that and read all about it. If you take any photographs, even with your camera phone, do send them into the magazine for publication. Then that night as well, Jupiter is closest to the moon. So you'll see the Jupiter blazing next to the moon, 6 degrees away, not particularly close. You'll just about squeeze Jupiter and the moon into the same binocular field of view, but Jupiter's going to be the brightest star-like object in the sky that night. You won't miss it. As I said, clocks go forward later that night. They go back an hour. Actually, that means we get an extra hour sleep. We lost it back in March. Now we're going to get it back. And then the next, in fact, if you keep watching, the moon will actually, once the eclipse is over, will actually keep getting closer to Jupiter. That's a lot about that in the magazine. Do watch out for it. Let's hope for clear skies. In fact, Jupiter's at opposition on November 3rd, which means it's closest to Earth, therefore it's brightest and best. And then just going up to our next lecture in November, on Thursday, the 9th of November, in the morning, Venus is going to be occulted by the moon. The moon's going to pass in front of Venus. Now, there'll be more about that in the November issue of the magazine, which will be out at the end of October, but just to warn you in advance. A lot of this in the magazine. Enjoy the magazine. So just to close, what events are coming up? Well, tonight, 10 o'clock, BBC 4, the Sky at Night Question Time special, repeated Thursday at 7 p.m. Then on Tuesday, the 17th of October, that's tomorrow week, we're running a Saturn watch. Saturn is incredible in giant telescopes. Do book your tickets for that on astronomy.ie and come along if you're in the Leinster area. It's an amazing site. It was a big event at the Starbecue we had back in early September. And then the main thing we're doing is this month is starting our evening classes for beginners. They're on every Tuesday starting October 24th. They had to be pushed forward a little bit. Plenty of time to book them. Thousands of people have taken these classes over the decades that we've been running them. So they're by far the most popular astronomy classes in Ireland. So sign up on astronomy.ie, tell all your friends and family to do so as well. And just to end, our next lecture is our November lecture, the 13th of November. That's actually Science Week. This is Space Week. Next November, it's going to be Science Week. It's meteorites is the subject by Dr. Ian Sanders. And you may have heard all about this meteorite that we thought had landed on a beach in Dublin. It turned out it wasn't. It was the hole somebody had dug with a guilty looking stone at the bottom. But it got us on television. And in fact, Dr. Ian Sanders and myself were on Virgin Media. Actually, we'll post a link to that in our chat box if you want to watch Ian and myself on television. And if you want to hear him again, book your tickets now on astronomy.ie for our November lecture all about meteorites. And Ian is a world authority on meteorites, not just the man in Ireland. When the last meteorite fell on Ireland, it was sold for 50 times the price of gold. Ian got a piece of it and confirmed that it was a genuine meteorite. So he's given as many talks in the past. What he doesn't know about meteorites isn't worth knowing. I highly recommend that talk to you as well. Follow us on Facebook, Twitter, Instagram for Aurora predictions, International Space Station times, and more. Just a reminder of what's in the magazine as well. Do join the society, order the magazine on the website. This has been Space Week. We've still got one more day to go tomorrow. So do enjoy all the details. You'll find more details of Space Week on our website, astronomy.ie. Follow the Space Week link there. That's everything, unless I've forgotten anything from our volunteers who are watching in. I think we'll thank Ezzy Pearson again for her talk and look forward to seeing you all next week, if not at the Saturn Watch or the evening classes between now and then. Thank you very much for joining us. Right, I don't see any questions in the chat box, so.
Right, you switch off the light.
You're online. I got 7 chats. I'll just check that nothing important has come up. Difficulty operating chat for some reason. Great. Well, I think that's everything. We'll close the meeting down. Thank you all very much.